In this video, we are going to learn how to use algebra to simplify trigonometric expressions. Now, I set up a few example scenarios of some techniques you can use to simplify. The first one being just rewriting everything in terms of sine and cosine functions. That could be a good way to help me simplify this expression into something different. So, we know that cotangent of theta is equal to cosine of theta over sine of theta, and cosecant of theta is equal to 1 over sine of theta. So I can rewrite this expression as cosine of theta over sine of theta over 1 over sine of theta. Now, we're dividing by a fraction here. So whenever we take cosine of theta over sine theta and divide it by 1 over sine theta, we're actually multiplying by its reciprocal. You'll see this happen quite often while you simplify trig expressions. And then from there, you can see that the sine thetas cancel, and we're left with just cosine of theta. So that expression, those two different trig functions, could have been simplified just down to cosine of theta. Now next up, I want to show that these two things are equal. Cosine of theta over 1 plus sine theta is equal to 1 minus sine theta over cosine theta by multiplying the numerator and the denominator by 1 minus sine theta. So we're going to go from the left to the right. And the reason why I'm choosing 1 minus sine theta is that is the conjugate of 1 plus sine theta, and that can sometimes lead to a identity when you start squaring something, because this leads to difference of squares if we multiply by this. So if I multiply the top and the bottom by 1 minus sine theta all over 1 minus sine theta, since these are conjugates, the denominator becomes 1 squared, which is just 1 minus sine squared, so sine squared theta. And up top, I'll have cosine times 1 minus sine theta. Now, this 1 minus sine squared theta, we have a squared trig function, so we should think Pythagorean identity here. Which is sine squared theta plus cosine squared theta equals 1. And that's 1 minus sine squared theta, so if I subtract sine squared from either side of this identity, I get cosine squared theta is equal to 1 minus sine squared theta. So 1 minus sine squared theta can be replaced with cosine squared theta. So we have cosine of theta times 1 minus sine theta all over cosine squared of theta. Now one of these cosines can cancel out with one of them in the denominator, and you're left with 1 minus sine theta in our numerator over cosine theta, which is another way to write it. And when it's in this form, I can do a clever trick of thinking it as 1 over cosine minus sine over cosine, so secant minus tangent if I wanted to do that. But earlier, I can't split up 1 plus sine theta since it's in the denominator. So this is a much better form for it to be in for me. Now next up, it wants me to simplify this expression by rewriting the expression over a common denominator. So sometimes we'll be given two expressions with different denominators, and just finding a common denominator can sometimes lead to a simplification. So in order to simplify this, I'll take 1 plus sine of u over sine of u, and I'm going to multiply that by cosine of u into the numerator and the denominator. So then now this denominator will be sine of u, cosine of u, and I'm going to do something very similar to my other denominator, because that's going to be plus cotangent u minus cosine of u over cosine of u times sine of u over sine of u. So now when I rewrite this expression, it'll all be over the same denominator. But I'll distribute the cosine, so I'll get cosine of u plus sine of u times cosine of u plus cotangent of u times sine of u minus cosine of u times sine of u all over sine of u times cosine of u, with that being the common denominator. You'll notice here that the sine of u, cosine of u is positive, and this sine of u, cosine of u is negative, so that will cancel, and we're left with just these terms in our numerator, which I can rewrite as cosine of u plus, and cotangent we just went over earlier is cosine over sine. So cotangent can be rewritten as cosine of u over sine of u, which is times that sine of u. Which within the sines cancel, I'll just have cosine of u plus cosine of u all over sine of u cosine of u. And I'm going to go into this other area down here to show you that this continues to simplify, because now I'll have 2 cosine of u over sine of u cosine of u, where those cosines will cancel. And I'll be left with just 2 over sine of u. Which is also equal to 2 cosecant of u. So either or, but that's down to one trig function, which is already better than that crazy expression I had to begin with. So sometimes if you continue to simplify, eventually you'll get down to one trig function. Now lastly, we can simplify by factoring. And the way we do this is I see here I have sine squared v minus 1, which could be thought of as x squared minus 1. And I can factor it using difference of squares, which will be x plus 1, x minus 1. And this is where x is equal to sine of v. And I can rewrite this expression on the left as sine of v plus 1 times sine of v minus 1 all over tangent sine v, tangent v sine v minus tangent v, which this also has a common factor, which I don't have to factor like x squared minus 1, but I could just factor out a tangent of v, and I'll be left with sine of v minus 1. And you'll see here there's a common factor that could be canceled out, giving me sine of v plus 1 all over tangents of v. So again, that same scenario that we see over here, now there's one function in my denominator. I could think of this as sine over tangent plus 1 over tangent, which I could maybe do more simplification on to rewrite as another expression. There are many techniques, and it's just going to take practice of trying them out, and I'll usually give some direction as to what you should use, but you can always simplify these trigonometric expressions using algebra. And that is how you use algebra to simplify trigonometric expressions.